Okay, when you're factoring expressions, you always want to check for a GCF first. And that is greatest common factor, a number that I can divide both terms or all the terms by to reduce them in the same way. So if I'm looking at 48x to the fourth and 18x to the fifth, what do those have in common? Well, they both have at least 4 x's in them, so I can take out an x to the fourth, and that would leave me with just an x in the second term. And then as far as the 48 and the 18 goes, let's see, 18 is 3 times 3 times 2, and 48 would be 3 times, I think, a bunch of 2's, maybe. So it looks like our common thing would be 6. So if I take a 6 out of 48, that would be an 8. And if I take a 6 out of 18, that would be a 3. So that's factored completely. So let's look at this next one. I've got 3x to the fifth, and I've got 7x. There's nothing in common between 3 and 7. Those are both prime numbers, so I'm still going to have a 3 and I'm still going to have a 7. But they both have at least one x that I can take out. So I can take out an x, and that would leave me with 4 x's here and none with the 7. So that would be factored completely. This is my GCF, but remember, your GCF is still part of your result. Sometimes students may think that, like, these both have a 3 in common, so let me take out a 3. And that's a common factor, but it's not the greatest common factor. So sometimes you may have more factors that you can take out. If that's the case, they all get multiplied together. So like if I took out a 3 and I was left with a 16 and a 9, or sorry, a 6, 16 and a 6, I realized that 16 and 6 have a 2 in common, so I could take out another 2, and that 3 and 2 would combine to give me a 6. Okay, here we have trinomials, and so we're trying to figure out what two things multiply together to give us this trinomial. So I know I need an x squared, and I know I need a 15, and then these two terms are going to combine to give me an 8x. So what two things will multiply to give me x squared? That would be an x and an x, right? And then to get a 15, I either need a 1 and a 15 or a 3 and a 5, or the negatives of those. Since there's no negatives in here, I don't really need to worry about the negatives. But I need numbers to go here that will end up multiplying times these x's, and those are what have to combine to give me 8. So I need to pick the ones that combine to give me 8, and that would be 3 and 5. So my result here would be x plus 3 and x plus 5. Or you could write it the other way around. It means the same thing. So either of those solutions will be good. Okay, over here we have x squared and a negative 8, and then two things that should combine to give me a positive 7. So we know it's going to be x and x to give us x squared. For the negative 8, we either need a negative 1 and an 8, or a 1 and a negative 8, a negative 2 and a 4, or a 2 and a negative 4. So which of these options will combine to give me a positive 7? That'd be a negative 1 and a positive 8. So my answer, x minus 1, x plus 8. So here's where we kick it up a notch. This is still a trinomial, but the difference here is this leading coefficient is not a 1. So we need something that multiplies to give us 5x squared. which would have to be a 5x and another x. And then these two terms are going to combine to give us negative 14x. But remember, this one is multiplied times a 5. So we need to multiply to get 9, which would be 1 and 9, or the negatives. And since there's a negative here, I want to consider those negatives. And then 3 and 3, or the negatives. Okay? So in order to get 14, let's see, if I put a 9 here, this would be 45. And I would have a 1 here, so 45 and 1 would give me 46. So if we test it the other way around, so maybe instead of putting a 9 here, we put it over here. That would give me a 9x. And then if we put the 1 up here, that would give me a 5. And the 9 and 5 do combine to give me a 14. But if we want a negative 14, then we need the negatives. So this gives me the negative 14 that I need. So my result would be 5x minus 9 and x minus 1. So same idea over here. We need two things that multiply to give us 2x squared. That would have to be a 2x and an x. And then we still need two things that multiply to give us 9. So we can use these same guys as our options. And these need to combine to give us a negative 11x. So if I tried a 9 here, that would be a 9x. I'd have to have a 1 here, so that would be a 2x. So 9 and 2, that gives me 11. Since I want negative 11, we want to make it a negative 9 and a negative 1. So that gives me that negative 11. So 2x minus 9 and x minus 1. Or, of course, you can reverse that. And either answer is acceptable. Okay, both of these options are difference of squares. So difference of squares means I have something that's squared minus something else that's squared. That's where the term difference of squares comes from. And those will always factor to first minus second and first plus second. So your task is to sort of figure out what has been squared. So in this case, 1 squared is 1. And in this case, we have 100, which is 10 squared. We have x squared, which is x squared. And we have y to the 4th, which is y squared squared. So 1 operates like my a, and 10xy squared operates like my b. So when I factor this, I would have 1 10xy squared and 1 10xy squared. Same for this one over here. What squared gives me 64? That would be an 8. And x to the 4th, that would be an x squared that has been squared. And then for the 9, that would be a 3 and a y. So the factored form would be 8x squared minus 3y and 8x squared plus 3y. This is something that you need to know. You need to have that pretty memorized. This next section is the sum and the difference of cubes. It's sort of like difference of squares. You're going to have something cubed plus something else cubed. And that's going to factor, we don't really need these parentheses here. That's going to factor to those two terms. And then the first one squared. Those two terms multiplied together, subtracted, and then the last term squared. And if it was a difference of cubes, then these two signs would change, but your last one would stay a plus. Okay, so for 1 minus n to the third, that's the same thing as 1 to the third and n to the third. So 1 operates like my a, so I'm going to have a 1 squared, and a 1, where all the a's are. And n operates like my b, so I'm going to have a b, a b and a b squared. N, sorry. So we would have 1 minus n, 1 squared, 1 times n squared. Okay, this next one, 27 is the same thing as 3 to the third. And then 64 is 4, and the w is also to the third. So 3 operates like my a, and 4w operates like my b. So I'm going to have 3 minus 4w, and then I'm going to have 3 squared plus, and then this is a times b, so 3 times 4w, that's 12w, and then my last term squared, so 16, and then w squared. Okay, this would be 3 and a that are cubed, and this would be 2 and b that are cubed. So I'd have 3a plus 2b, and then I would square that, and then I would multiply them together, and then I would square my second term. Okay, this last section sort of combines everything. So you want to check for a GCF. First, if it's a trinomial, you'll use that box. And then if it's a binomial, it's going to be either a difference of squares or it's going to be a sum or difference of cubes. So that's kind of like combining all of it together. Okay, so for this first one, we want to look for a GCF first. And it looks like I can take a negative 2 out of all of these, but also an x squared. So if I take a negative 2 and an x squared out, all of these will become positives now because I took out a negative. So what times negative 2x squared would give me negative 4x squared? That's just x squared. What times negative 2x squared would give me negative 34? X to the third, I believe that's 17x. And then this would be 70. Okay, so now I've got this trinomial. So I'm going to think about what would multiply to give me x squared, 70, and then something plus something to combine to give me 17. So I know it's got to be x's, and then for 70 there's a lot of different options, but if I want to add to get 17, it would be a 7 and a 10. So I'm going to keep this negative 2x squared, and then I have x plus 7 and x plus 10. Okay, for this next one, we still want to check for a GCF first. So I know I can at least take a 5 out. So if I did that, I would have, I think this is 16 and 25. And then since this is a binomial, is it a perfect square or a perfect cube? Well, 16 is the same thing as 4 squared, and x to the fourth is x squared squared, and then this would be 5 squared. Okay, so that means I can just treat it like a perfect or a difference of squares. So I would have 4x squared minus 5 and 4x squared plus 5. And this GCF just stays with my factored form.